In this video, I want to talk about the various health problems that you can encounter with bones, the most obvious of which is breaking them, right? So that's relatively straightforward, what happens when a bone breaks. Maybe let's draw ourselves a stress-strain curve and think about what would happen with a bone break. That's like you just go up like this and then boom. The stress, because the stress is force divided by area, remember, that goes up and then you just completely break the bone. All right, that's pretty straightforward. You can imagine, by the way, that our body's ability to heal bone damage likely has a lot to do with being able to survive bone breaks and not just be completely useless for the rest of your life. It's quite remarkable that we can recover from even pretty aggressive bone breaks. There's also something we'll talk more in detail about at the end of this unit is stress fractures, which is when you have small little, and by the way, we're looking at this is a high resolution CT scan of the forearm, radius and the ulna. I think so. I think so. This might actually be the tibia because this is much bigger. In any case, this is a bone, a long bone. And stress fractures are like little microscopic areas of damage that can occur even when you're maybe down in here on the stress strain curve. If you repeatedly expose yourself to those stresses over and over. And those can gradually get bigger and bigger and bigger. And then once they get to a certain point, they start causing a lot of pain. And in fact, if you continue to train on a stress fracture, it's causing a lot of pain, eventually it will just completely fracture through and you'll have an actual bone break. So those are maybe the two obvious sports-specific sports medicine bone problems people have, and you're probably familiar with them. The other health issue I want to talk about is osteoporosis, which you've probably heard of. And that has to do with when this microarchitecture inside the bone gets hollowed out too much. And by hollowed out, I mean both the cortical bone here and the interior of the bone as well, because that does contribute to some of the mechanical strength of the bone. Here we go. This is what I want to look at. This is an MRI and a computational model of the distribution of strain, meaning change in length over the original length, percentage change in length. And we know that if that strain gets too high, then you end up here, right? So too much strain, bad. And we're looking at the head of the femur. It's kind of a funny view. This is like this is the distal end, this is the proximal end of the femur. And then this goes down to the knee joint down here and the hip is up here. And so this is the, frontal plane, but the body's sort of laying on its side. We've got a young cadaver, old cadaver, and it's hard to see the difference here. And in fact, even when you look at this computational scan of the strength of the bone, you can notice, okay, there's some areas of lower bone density here, some areas of lower bone density here. It looks like the bone's been almost like hollowed out. And then when this computational model of the microstructure is subjected to stress, subjected to force, such as the force you experience when you're standing and your body weight is going through the head of your femur, now we can see that in this young cadaver, the distribution of strain is not so bad as in the old cadaver. You've got all of this strain in here, whereas just these isolated little areas here and here. So osteoporosis, and let me write that out. Osteo means bone, we know, and then porosis, literally like porosity. It's like you have holes in your bone. That's from the density of your bone goes down and the microscopic architecture gets, let's say, worse. A more subtle point to this is that you can actually have the same you can have the same bone density, but worse microarchitecture than somebody else. So it's kind of hard to see here, but both the structure of the cortical bone and the structure of this interior here have to do with how strong the bone is, both in absolute terms and in terms of its density. So there are more and less efficient ways to organize a set amount of bone. You could imagine this. I don't know if maybe you did this in this exercise in elementary school. If you like build a bridge with toothpicks, there are better and worse ways to arrange the same number of toothpicks into a bridge that's either stronger or weaker. The same thing is true with bones. That turns out that there are better and worse ways to arrange this microarchitecture. And surprise, surprise, the best way to get really well arranged bone microarchitecture is to do lots of high intensity, high impact, high loading physical activity. So osteoporosis happens when that bone density and bone microarchitecture is declining, not being so good. And one way of thinking about it is that it is overactive overactive, or relatively too much activity in the osteoclasts. Because remember, what those do is they cleave away old bone. And if that happens at a rate that exceeds the rate at which you build new bone, you get this and not this. So perhaps you are familiar with the fact that there are medications for osteoporosis. Common category is something called bisphosphonates. I think I'm spelling this right. And what those do is those downregulate the activity of osteoclasts. An interesting piece about this is that for a while, the military researched whether or not those would be useful for preventing stress fractures. And it turns out they're not, because if you shut down osteoclasts, that means you can't eat away at the old damaged bone and build new bone. Another term you might see is osteopenia. And that is just a precursor to osteoporosis. So this is like a less serious version of this. And if you remember from a few weeks ago, one of the major areas in which this is diagnosed is with DEXA, which I should note, by the way, has some limitations, which I alluded to earlier. Just because you have high bone density does not necessarily mean the microarchitecture is arranged in a beneficial way. So I don't have answers for what a better way to do this is. That's still an area of active research. But hopefully this has been a useful insight into how some of these things we've learned about bones can be applied to the kinds of health problems that we have with bones.